Hi, thank you so much for joining me today. We are going to talk all about how to find the missing side lengths of shapes that are similar. And I am going to show you two different ways to do that. Here we go. Here are two shapes and they are similar. So when you're looking at shapes and you know they're similar, the first thing you want to do is kind of look at it and see which sides are corresponding side lengths. Let me show you what I mean. So in this example, the red side lengths are corresponding to each other. They are in the same spot on both of these shapes, so they have a relationship there. The blue side lengths, those are corresponding side lengths. The green side lengths are corresponding, and then the purple side lengths are corresponding. So if I want to figure out this missing side length, that red one, I can choose if I want to compare it to this red one. But before I do that, I would need to figure out the scale factor. So let's look at that first, and then on our next problem, I'll teach you how to do it the other way. So the first thing I notice is to get to this shape, you would have to multiply it by a scale factor of 2. 7 times 2 is 14. 6.5 times 2 is 13. So I would just need to think what times 2 is 8. You could also think about it the opposite way. To get from the large shape to the smaller shape, that would have a scale factor of 1/2. 14 times 1/2 is 7. 13 times 1/2 is 6.5. And 8 times 1/2 would give us 4. So the scale factor is always the number that you would multiply the side lengths by. And when we have a missing side length, you could use the scale factor to figure out what that side length is. So this one would have to be 4. So let me show you a different way to solve this on the next problem. Here is our next problem. So if I wanted to solve this problem the same way we did it last time, I would have to think, well, what would be the scale factor to go from 24 to 18? And the reason I chose those numbers to compare is because those are corresponding side lengths. This side length corresponds with that side length. They are in the same spot on the different shapes, okay? But I do not want to do that. I don't want to think what times 24 is 18 or what times 18 is 24. I want to do something a bit easier. And what I notice is this ratio inside this smaller shape, 9 to 18, I notice that this is half of this. So if we look at our larger shape, this side length up here should be half of what this is. So the two ways to find missing side lengths when you have similar figures is either to find the scale factor, or you could look at the ratios within one single shape. So the ratio from 9 to 18 is 1/2 or 1 to 2. So that's going to be the same ratio here, which would tell us that this side length must be 12 because 12 is half of 24. Let's try another one, and I want you to think which would be the easiest method to find the missing side length. Okay, if we had these two triangles and we wanted to figure out that missing side length, and I had to choose from those two different ways, which way do you think would be easiest? Do you think I should try and see if I can see a relationship between these two numbers, 6 or 7? Or do you think I should look for the scale factor? Can you tell what number 6 was multiplied by to get to its corresponding side of 2? Or can you tell what 2 was multiplied by to get to its corresponding side length of 6? I bet you know that 2 times 3 is 6, or 6 times 1/3 is 2. So you can ask yourself, what times 3 would give us 7? Or 7 times 1/3 would give us what? So 7 times 1/3 is the same as 7 divided by 3. So we can write our answer as being 7/3, or we can write that as simplified, being 2 1/3. Or if you used a calculator and did 7 divided by 3, you will get 2.33 repeating, okay? So for this example, I think it would be easier to use the scale factor method instead of looking at the ratio within a triangle. Let's practice another one. Here is our next problem. So you could probably think about this one both ways. You could think, what is the scale factor from 16 to 24? Or you could look at the relationship between 6 and 24, and these corresponding sides will have that same relationship or ratio. So if you do it the first way, you might think, well, 16 times 1.5 equals 24. You might be able to figure that out. So you might think, what times 1.5 would give me 6? Or you could think the ratio 6 to 24, or 6 divided by 24, is 1/4. 6 is 1/4 of 24. So you could think, what is 1/4 of 16? So either way, you should get a missing side length of 4. Once you get good at these, you're going to just find the easiest way all the time. You will know whether you want to do it the scale factor way or the ratio within the shape way. Okay, let's do one more. Here is our last example, and I want you to just think about what would be the easiest way to find this missing side length. Okay, so you might see a relationship between the numbers 3 and 10, and you might think, how would 3 get to 10? Or how would 10 get to 3? But honestly, I wouldn't do it that way. That's a lot of thinking. You totally can do it that way, but I see an easier way that has friendlier numbers. So I'm going to compare this corresponding side length to this corresponding side length, and I want you to think, what would the scale factor be to get from 10 to 25? What do you multiply 10 by to get to 25? 1 times 10 is 10, 2 times 10 is 20, 1/2 of 10 is 5, so 2.5 groups of 10 would give us 25. So 10 times 2.5 is this. So what would 3 times 2.5 be? Well, 3 times 2 is 6, and 1/2 of 3 is 1.5. So 6 plus that 1.5 should give you 7.5, and that would be your answer. Hopefully this makes sense. If it did, don't forget to give me a thumbs up and subscribe below, and let me know if you want more practice finding the missing side length of similar shapes. Bye!